much dominated at that time. And these were pretty much just hydrogen and helium nuclei for the most part, and trace amounts of lithium. And the lithium ones are not worth mentioning too much at this point. We will just note that there were trace amounts of lithium. Mainly it was the hydrogen nuclei. We say nuclei because really at this point we don't have neutral atoms yet, you know, with the electron being near the nucleus and all that stuff. It's just mainly the nuclei and how the nuclei are forming, with or without, of course, the neutrons. If you had just the proton, one proton only, one p, then you would have the hydrogen nucleus. If you had a neutron along with it, you would have deuterium. If you had two neutrons along with it, you would have the tritium. And then if you had two protons together, you would get the helium nucleus. And depending on, again, neutrons or not, you could get the helium-4 nucleus. So we're pretty much we're talking about hydrogen and helium nuclei at this point. Suji, let's not do that. And we even see a local maximum for the helium-4 binding energy, giving us a stable nucleus for helium-4 in that particular environment. So what basically we were able to make nuclear physics like back during the Big Bang Nucleosynthesis is going to be important, because that's what we expect to get during those early universe times. And later on, we will make the other elements, the heavier elements in the stars. But it's good to understand sort of the makeup of the universe back then, because then that's all we'll really look for, or when we find something where it's like, okay, it's consistent with what we thought, because of what we know about the energies and temperatures of that time. We don't expect to make other types of nuclei. We are not in that environment yet. We could have smooshed together more helium-4 nuclei to make carbon, which we will do in a star later on, but they simply did not have enough baryon number to accomplish that in those Big Bang nucleosynthesis periods of time. The photons were more in number, very energetic, and hitting everything and everyone, making them too excited to be able to stay stable. So that's kind of what we're talking about here. I'm making some tea. Stick around for the rest of the discussion. Thank you so much for joining the live. Hi, Suji Mama. Look at this girl. Look at this girl. Hi. Hi, Suji Mama. Hi. Hi, Molly. Did you say how your stuff was going in school? I don't think I saw that. Hi, Fuji. Hi, Suji. Ooh, and who is this over here? Baji Wawa. Baji. Who is this? Who is this? Is this a Baji baby? I think I know a lot about plants and nature. Plants and nature, what to eat and what not to eat. Oh, wow.